Hello everyone, welcome to Maths Bridge. I hope you are all doing great. Have a happy learning. Today we shall continue our learning journey in machine learning. Let's get started in today's topic. Quote for the day: Machine intelligence is the last invention that humanity will ever need to make. Said by Nick Bostrom. In today's agenda, we shall explore unsupervised learning concepts in detail. For more learning videos, please do visit us at our YouTube channel at Maths Bridge. Okay, please do subscribe the channel if you are yet to be. Thanks for all your support. As you know, machine learning can be classified as a supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. Right? In supervised learning, we will give input data along with labels. Labels are representation of teacher teaching in process of you building concept of learning, isn't it? So in unsupervised learning, other way around, you would end up seeing wherein you have the data but no labels, meaning you are learning without teacher. Since there is no teacher involved in your learning, we named it as a unsupervised learning. Unsupervised learning. Let's look at details. Let me recap what we learned in supervised learning before getting into the unsupervised learning. In supervised learning, for algorithm, do you remember what the inputs are? The input for the supervised learning is input data and then labels, right? Input data and the labels are the input to the supervised learning. So label means as an output data corresponding to input, because you know what's supposed to be predict, right? That's why supervised learning have a known data along with a label, and hence algorithm learned by that supervision, like assuming that you are learning with the help of a teacher in your classroom. That is how you resemble the supervised learning. Now coming back to unsupervised learning. In unsupervised learning, assuming that you have a classroom without teacher but you are in the process of learning things. Okay, learning without teacher supervision is known as unsupervised learning. Don't you feel this is like a difficulty, having teacher versus like not having a teacher? Yes. In this context, what we are reiterating the definition of unsupervised learning, where the input to the algorithm is input data set but no label, means there is no corresponding output data known to you. Okay, then you might have a question stating that why would we need unsupervised learning? Yes, we do need the unsupervised learning. For instance, there may be many real-time use cases in which you do not have a label data. However, you would end up need to find the hidden patterns and insight from that given data set. But how would you solving? Definitely you are not going to use supervised learning, because this case doesn't provide any label data. then definitely you need unsupervised learning techniques to resolve this type of machine learning use cases. Does it make sense? Let's look at a quick reference. This diagram depicts in generic process how you see in supervised learning. Assuming that you have unsupervised learning algorithms, which build keeping in the interest of you are having no training data set, unknown output. However, there is a raw data set that you are going to give as an input. Then this unsupervised learning algorithms takes this criteria and do data processing and generates an output. That is how you would see what happens in unsupervised learning. So key takeaways: unknown output, unlabeled data, no training data set. That's what you always imagine. This is how I think the human learns without elder supervision. Okay. Unlabeled data is analyzed and categorized by the computer based on similarities found. The primary purpose of these algorithms is to unearth previously unseen pattern in data. Let's look at a simple example. Let's assume that you are supplying a raw data which is known as a unlabeled data. This is given to the model, means unsupervised learning algorithms. So what it does basically, since I do not know the label, meaning the output for the given input data, so what I was trying to do, I will analyze the data, unlabeled data, and categorize based on similarities that it sees within the data. So algorithm is left to discover patterns and a relationship within the data on its own to cluster the data that makes sense to us. So if you look at, there are the three different types of data that is available as an input, but it is kind of like a raw data, mix and match. What the model does now, try to find out the similarities and then group them separately and having them output as a three clustered data. So each cluster is having a similar characteristics of the data. This is what unsupervised learning does for us. Unsupervised learning is much similar to a human, how it learns to think by their own experiences, which makes it closer to real AI. Unsupervised learning helpful for finding patterns and useful insights from that unlabeled data. That's one takeaway that you can consider. So the challenging part is here. The result of the unsupervised learning algorithm might be less accurate as input data is not labeled and algorithms do not know the exact output in advance, like in supervised learning. The goal of unsupervised learning is to find out underlying structures of the dataset and group that data according to similarities and represent that dataset in a compressed format. So this is how you can conclude the how unsupervised learning works in overall. Look at the high level diagram which depicts the process flow which we use in unsupervised learning. Data collection, data processing, choose clustering algorithm, determining the number of clusters, training the model, analyzing the clusters, visualizing the clusters. These are the steps that we follow as part of unsupervised learning process flow. Now you guys remember this is very important and then easy to follow the process. Let's look at a simple use case how we do things in unsupervised learning. For instance, customer segmentation. So we have seen just now there are the 7 steps that we use as a process flow in unsupervised learning. The first step is data collection, right? From the given problem domain area, you are going to gather the relevant data. Gather the data on customer behavior and demographic. Something like a customer ID, age, annual income, spending score. A score is assigned based on the customer spending habits. Now let's have all the data collected. What would be the next step? Data processing. Something like handling missing values, feature scaling, etc. Once your data processed, that means like you have a quality data with you. So now you have to look at what sort of algorithm that you have to use. Precisely we talk about choose clustering algorithms because we are in unsupervised learning which has a data set without a label, right? Unlabeled data, and hence we are going to go for clustering algorithms. So you choose a clustering algorithm, one of the algorithm, there may be many, but you can choose an algorithm to determine optimal number of clusters for a given data set. That is how this step is going to help. Once you have this algorithm selection is done, then determining the number of clusters. How you are going to do that? Now you are going to choose either classification algorithm or the regression algorithm. So let's assume that you are going to choose a classification algorithm for this instance. For example, logistic regression is what you are going to use for classification because you are going to have a customer segmentation from the given data set. So now you have complete process data and you also chosen a clustering algorithm. Then you also know that like how you are going to find out a number of clusters and you are ready to train the model. What that means, fit the logistic regression model on the training data. Is it? Once you have trained model ready, what you have to do? Analyze the cluster. So examine the characteristics of each cluster. Once this step is done, you visualize, right, the cluster information, like plot the clusters to understand their distribution. This is how a process flow in unsupervised learning. So unsupervised learning is to segment customers into different groups based on their purchasing behavior using clustering algorithm. For instance, k-mean algorithm, k-mean clustering. This is an example, but you have many use cases which help you to understand various scenarios for which you could think of how unsupervised machine learning algorithms helps. Now that we have seen types of machine learning like supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, let's get into little more classification details of unsupervised learning. We could widely see clustering, association rules, dimensionality reduction are part of unsupervised learning. Clustering means, in brief, it is a data mining technique for grouping unlabeled data based on their similarities and differences. Okay, we could see k-mean clustering, hierarchical clustering, DB scan, mean shift clustering are algorithms which we use in clustering. Let's come to association rules. It uses different rules to find relationship between the variables in the given dataset, like a recommendation system. So typical algorithms that we can see in association rules that uses a priori algorithm, frequent pattern growth, Euclid algorithm. Now let's look at a dimensionality reduction. So you could see the sense of dimensionality reduction. When you have so many data inputs, that it's very difficult to process all of them and then extract insight that you look for it. So what you would do normally, reduce the number of data inputs to the manageable size, while preserving the data integrity. That is what dimensionality reduction helps you in unsupervised learning. Typically you could see widely principal component analysis, independent component analysis in dimensionality reduction. Here are the few applications of unsupervised learning: customer segmentation, anomaly detection, market basket analysis, dimensionality reduction, image compression, clustering, social network analysis, and then many more. Okay, some of them I listed, but you can still explore all other applications where you could use unsupervised learning. In customer segmentation, if you could see that use cases, market strategy, personalized recommendations, targeted promotions are some of the use cases we could see here. In anomaly detection, fraud detection in banking, network security, fault detection in industrial systems. Retail, recommendation, inventory management are part of market basket analysis. Dimensionality reduction, where you could see like a data visualization, noise reduction, improving computational efficiency. Whereas image compression application, what you could see as use cases, efficient storage and transmission of images, reducing the bandwidth usage. These are the scenarios where you can use image compression, which is a part of your unsupervised learning. Document clustering, image segmentation, customer segmentation like and pattern recognition are the typical use cases for the clustering. Understanding of social dynamic, marketing, network optimism are some of the use cases for the social network analysis application. Like you could think of numerous applications where we will use unsupervised learning. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.